Good morning, and welcome to our lesson for Thursday, July the 16th. Today, we are going to talk about Chapter 4 in your textbooks, which is entitled Measures of Central Tendency, the Mean, the Median, and the Mode. All right. Now, the mean, the median, and the mode are things that you've probably talked about since middle school math, maybe, certainly high school math. All right, and so you should have a reasonably good idea about each of these measures. However, we're going to add to that a little bit so that you understand exactly when to use these things. It's one thing to be able to calculate them and be able to identify what number is the median, what number is the mode, and so on. But it's also important that you know when to use these in scientific research. When is it most appropriate to talk about the mean? When is it most appropriate to talk about the median or the mode? All right. So these are this is the point of Chapter 4. We're also going to delve a little bit into measures of variability, but we'll get to that in a little while. So the goals of Chapter 4 are to determine what measures of central tendencies tell us about the data. All right. In other words, each of those three things that we've talked about, what do they do? And what information we can glean about a data set based on the mean, the median, and the mode. Secondly, what the mean, the median, and the mode are, and when each is appropriate. All right, so the first two are kind of closely related there. How a sample mean is used. What that actually tells us and what we can do with it. What deviations around the mean are. Now, as I said a minute ago, these deviations are actually measures of variability, but we'll get there. And then last but not least, how to interpret and then graph the results of an experiment. Now, in order to go through this unit, there's a couple of things that we need to make sure that we understand, all right? And this is new statistical notation. The first thing that you need to be aware of is this symbol right here, okay? This is the Greek letter sigma, all right? And it's very important in many mathematical contexts, but it's very important in statistical analysis, especially when you're looking at a data set that's comprised of a lot of different points. Now, if you put sigma in front of a variable like x, all right, and so you've got the symbol sigma x, that means to sum or to add up all of these scores that are x. Now, we did this a little bit yesterday, or Tuesday rather, when we calculated deviations in science. Delta, or sigma x is simply the sum of all of the x scores, okay? And so you pronounce this symbol, sigma x, as the sum of x. You don't have to actually say sigma x, you say the sum of x, because sigma means the sum of. Okay, so what exactly is central tendency, okay? What this means is that if you have a data set, what are the values that are most representative of that data set? In other words, what's the average of the scores that you're looking at here? That's really what central tendency is. And although you may not have heard this before, it turns out that actually mean, median, and mode are all averages, right? We tend to say that the mean is the average of a data set, but in reality, means, medians, and modes are averages, okay? So in reality, we talk about central tendency. What's the middle of this data set look like? What do we do to describe this data set? Okay, so a measure of central tendency is a score that summarizes the location of a distribution on a variable. Okay? A measure of central tendency is a score that summarizes the location of a distribution of a variable. Okay? It should be on a distribution of a variable. Sorry about that. Now, what does that mean? Well, that means, what does the middle of the data set actually look like? All right, and so it's a number that indicates where the center of the distribution tends to be located. Now, the mean, the median, and the mode may not actually even be one of the data points in your set, okay? But it represents the middle of that data set, the center of the distribution. And again, this goes back to what we were saying about the bell curve. All right, right at the very peak of the bell curve, that's if it is a completely normal distribution, that center point is not only representative of the mean, but it's also the mean, the median, and the mode. All three measures of central tendency. Okay, so the central tendency idea is just, where is the middle of this data set? Right, that's really what it boils down to. Okay. So how many of you know what the mode of a data set is? We'll start with the one that's easiest to determine, okay? What the mode is simply the number, the score, I should say, that appears most frequently in a given set of data, all right? And so if you look at a data set and you notice that one score appears more frequently than any other score, that's the mode. All right. And, we have several examples of this. And you saw some in science. But if you had 1, 2, 3, 3, 2, and 3 as your data set, okay? The mode here is going to be 3, because 3 appears 3 times. 2 only appeared twice, and 1 only appeared once. And so therefore, the mode in that example would be 3. All right, so by definition, the mode is the most frequently occurring score in a given data set. All right, the most frequently occurring score in a given data set. And the mode is typically used when the scores reflect a nominal scale of measurement. So I think we did this. All right, so if this is my data set, all right, what I could do is build myself a frequency table. And so I'd have scores of 3, scores of 2, scores of 1. Now the frequency, just to keep this simple, the frequency of 3 was 3 because it appeared 1, 2, 3 times. The frequency of 2 is 2 because it appears 1, 2 times. And the frequency of 1 is 1. So because the frequency of the score 3 is 3, this is my mode, okay? Now, the mode is the most qualitative of all the measures of central tendency, meaning that we tend to use it when the scores reflect a nominal scale of measurement. Remember, a nominal scale of measurement is just when the numbers represent a group. All right, 1 for Republican, 2 for Democrat, 3 for Independent, 4 for Conservative, 5 for Liberal. Okay, and so if there were more independents in that group than any other political party, then independents, which I think was a 3, right? That would be the mode in that case. All right. Now, modes drawn on a frequency distribution can come in a variety of different shapes. All right. This is simply a frequency distribution drawn graphically, right? We've got the frequency on the y-axis and test scores on the x-axis, all right? God only knows what the maximum score on this test could have been, but it's very obvious that in this particular case, the number one, nobody scored a 1, one person scored a 2, two people scored a 3, four people scored 4, two people scored 5, one person scored 6, and nobody scored 7. All right. So which score appears most frequently? Well, that's the one here at the very top of this graph. All right. The maximum point on the graph. And in this particular example, this is what we call unimodal. All right, meaning that there's only one mode. Oh, that's an interesting thing. There could be more than one mode. Yes, indeed. We'll get to that in a second. When a polygon has one hump, such as on the normal curve, all right, this is not a normal curve because it's drawn with lines, but if we drew this, I kind of missed, but you get the idea. If we drew this as a normal curve, all right, then this distribution would be unimodal, all right, meaning that there's only one score that has the highest frequency in appearance. All right. In this particular example, the score of 4 appears 4 times, and therefore that is the mode. All right. It has the largest frequency, the highest frequency. Now, bimodal distributions are a little bit different. All right, the prefix bi simply means 2. All right, and so a bimodal distribution is when a distribution has 2 scores that are tied for the most frequently occurring score, and therefore we call it bimodal. Now, here's again frequency on the y-axis, test scores on the x. And here we've got a range of scores that ranges between 2 and 12. All right. Nobody scored a 1. One person scored a 2, a 3, and a 4. 3 people scored a 5. One person scored a 6, a 7, and an 8. One person scored a 9. And then, 3 people scored a 9. And then one person scored a 10, 11, and 12. And nobody scored a 13. So come on now. So in this case, there are 2 peaks to this graph, and therefore it is bimodal. Okay. Generally speaking, most tests and quizzes given by teachers and professors are bimodal. These are the kids who didn't study down here on this hump. All right. And then these are the kids who did study. And then there are some outliers, some really high scores, some really low scores, and so on. All right. But generally speaking, scores in most classes tend to be bimodal for any given test or quiz. All right. Because either everybody studies or nobody studies, or we get half and half. And typically in most classes, it's half and half. All right. And so we end up with a bimodal distribution. Okay, and that's what it might look like. Now, if we were to draw this as a quote unquote curve, then it might look something like this. And so you end up with a shape like that, like a 2-humped camel, if you will. All right, but that's where the bimodal distribution comes in. Okay, so let's move on from the mode and talk about what we call the median. All right. Now, the median is simply the number in the middle. Okay, and so if you have a set of scores, the median is the score that appears in the middle. What you have to do is you have to take the scores and you have to write them in order. So let's say we had that same data set. 1, 2, 3, 3, 2, 3. Okay. I'm going to rewrite this in order. 1, 2, 2, 3, 3, 3. All right. Now, in this case, I have an even number of scores, and so therefore, I can't just choose one single score. I have to look at these two scores. These are the two in the middle, right? And take the average. And so the median in this case would be 2.5. Okay. Now, let's say I get rid of this 3, all right? And so my data set is now 1, 2, 3, 3, 2. Okay. If I write this one out, it's 1, 2, 2, 3, and 3. And so in this case, my median is the score in the middle. All right, so this would be the median here. All right. So by definition, the median is simply the score at the 50th percentile. All right, the score right in the middle, right? 100th percentile is at the high end, 0 percentile is at the bottom end, and the 50th percentile, of course, is in the middle. All right. So the median is used generally to summarize ordinal or highly skewed interval or ratio scores. So ordinal, remember, is when the numbers are in order, all right, and the highest one is bigger than the lowest one. They're not just names, but they may not start at 0. Okay, they may not even have a beginning point, if you will. And so oftentimes the median is used to summarize ordinal scores. Right? They can also be used to summarize highly skewed interval or ratio scores. Remember, a skewed distribution means that it's pushed to the left or to the right. And when that occurs, oftentimes the median is a more accurate description of the data set. Generally speaking, that would occur when you have a few really, really low scores that are kind of outliers, or on the other hand, a few really, really high scores, which are outliers. Okay. If you calculated, for example, the average income in the United States, it would be very skewed because there's a few people who have millions or even billions of dollars. All right. And so therefore, the median income is much more accurate when it determines when you're talking about what the average American family brings home monthly or whatever you're looking at. Now, when the data are evenly distributed, normally distributed, the median and the mode are exactly the same. As a matter of fact, they are exactly the same as the mean. All right. So in a normal distribution, you end up with the mean, the median, and the mode all being the same value. Now, what is the mean? Now, oftentimes we use the word mean and the word average interchangeably. All right. Statistically, that's not really true because the mean, the median, and the mode are all three different versions of the average, which are used in different scenarios. All right. But if you were to say the average temperature, generally speaking, somebody's talking about the mean temperature there. And so we kind of use them interchangeably in colloquial English, all right? But in reality, in mathematics and statistics, they're not all the same. The mean itself is the score that's located at the mathematical center of the distribution. So it's not the median, it's not the middle score if you just write all the scores out and pick the one in the middle. All right, this is the mathematical center of a distribution, okay? The mathematical center. And the mean is probably the most frequently used calculation of average because it's generally, especially in a normal distribution, a very useful, the most useful, if you will, calculation of the average. The mean is used to summarize interval or ratio data in situations when the distribution is symmetrical. So in a normal distribution, okay? And so this is the most accurate and the most useful description of data if the data is in interval or ratio form, all right, and when the data is indeed symmetrical, okay? And so if you're looking at the normal distribution, this point right here on the x-axis, there's x there, and here's frequency here on the y-axis, all right? This point right there on the x-axis represents the average or mean value of x, all right? The average or the mean value of x. Now remember that in a perfectly normal distribution, it's also equivalent to the median or the mode, and the mode. Now, how do you calculate the mean value for a set of scores? Well, it turns out that this is a fairly easy calculation. You simply sum all of the values of x divided by the number of values of x, and that gives you the mean, all right? So this is the mean. This is, of course, as we learned in the first slide or two in this presentation. Come on now. This represents the sum of all of the x values, and this represents the number of x values. Okay. All right. So we are going to leave it here for now. This is the first of 2 videos on Chapter 4, and I hope you learned something.